November 12, 1943. 9:47 in the morning. The rain had not stopped for 3 days. Ernst Gottfried Kaufmann stood in what used to be a French colonial maintenance depot 8 kilometers north of Tunis. The corrugated metal roof had taken shrapnel during the fighting. Water dripped through the holes, hitting concrete that still smelled of diesel fuel and burnt rubber. Kaufmann was 52 years old. His hands were scarred and calloused from 15 years working with Panzer transmissions. The kind of hands that could feel a misalignment by touch, the kind that knew every gear by weight alone. On the workbench in front of him sat the transmission assembly from an American M4A1 Sherman tank, captured intact 3 days prior after a minor engagement near the coast. The tank had been abandoned by its crew when a Panther round penetrated the turret. The Sherman burned. The crew did not. But the transmission survived. Beside it lay a canvas-wrapped manual, American. Technical Manual TM9-731B. Olive drab cover, water-stained. Someone had stamped it, Property of U.S. Army Ordnance Department, in block letters across the front. Kaufmann wiped his hands on a rag that was already more grease than cloth. He picked up the manual, heavy, perhaps 2 pounds. He expected weight. German technical manuals for the Panther ran over 400 pages, detailed schematics, precision tolerances, step-by-step procedures for every conceivable repair scenario. He opened the American manual and stopped. For a long moment he did not move, did not speak. The only sound in the depot was rain hitting metal. Drip, drip, drip. Otto Heinrich Schmidt looked up from across the room. He was 45, a senior field mechanic with the kind of practical knowledge that came from working the Daimler-Benz assembly lines before the war. He knew machines. He knew production. He knew what was possible. "Ernst?" Kaufmann did not answer. Otto walked over, looked down at the open manual, saw what Kaufmann was seeing. Mein Gott! The transmission section was 4 pages long. 4 pages. The German equivalent for the Panther transmission ran 63 pages. Detailed procedures for disassembling the gear train, precise measurements for adjusting clutch plate clearances, step-by-step instructions for realigning drive shafts, tolerance specifications requiring precision tools and experienced hands. The American manual showed a diagram, the transmission as a series of numbered modules. Beside each module, a single instruction: remove and replace. No specifications for internal adjustment, no calibration procedures, no tolerance measurements, just 3 words repeated over and over: remove and replace, remove and replace, remove and replace. Otto read over Kaufmann's shoulder. His voice came out quiet. "Where is the rest of it?" Kaufmann turned the pages slowly, looking for the section that had to be there. The detailed repair procedures, the adjustment specifications, the craftsman's knowledge accumulated over decades and written down so that others might learn. It was not there. The manual explained how to unbolt the transmission from its mounts, how to lower it from the hull using a standard 2-ton hoist, how to install a replacement unit from supply, torque specifications for the mounting bolts, 95 foot-pounds. That was all. The old transmission was not to be repaired in the field. It would be sent to a rear depot, where it would either be rebuilt to factory specifications or scrapped entirely. Kaufmann read the procedure 3 times, each time hoping he had missed something, each time finding the same emptiness where complexity should have been. Behind them, the depot door opened. Lieutenant Heinrich Josef Vogel stepped inside, shaking rain from his cap. He was 28, educated at university, assigned to oversee the technical analysis team, young enough to still believe in the inevitable superiority of German engineering. "Well?" He walked to the bench, boots echoing on concrete. "Have you found their weaknesses?" Kaufmann set the manual down carefully. "Come look at this, Martin." Vogel leaned over the workbench, scanned the open pages. His expression shifted from curiosity to confusion, to something like contempt. "This is their technical manual?" "Yes." 4 pages for the entire transmission?" "Yes." Vogel straightened, laughed, short and sharp. Typical American shortcuts. This is why they lose tanks so quickly. They do not know how to properly maintain them. Otto said nothing. His eyes were still on the manual, on those 3 words repeated like a mantra: remove and replace. Kaufmann closed the manual, looked at the transmission assembly on the bench, then back at the manual. A thought was forming, not complete yet, but growing. "We need to understand this," he said quietly. "Understand what?" Vogel's voice carried the certainty of someone who had already decided what was true: that American mechanics are inadequately trained, that their equipment is designed for mass production rather than quality. "We already know this, Ernst." "Perhaps." Kaufmann picked up a wrench from the tool rack, hefted it. The weight felt right in his hand. He had carried tools like this for 15 years, each one an extension of himself. Or perhaps they have designed something we do not yet understand. The order from high command had been clear: analyze the captured Sherman, find its weaknesses, determine why American armored units continued to advance, despite fielding what every German tank officer agreed were inferior machines. On paper, it made no sense. The Panther had thicker armor, a more powerful gun, better optics, superior engineering in every measurable category. German crews who had faced both tanks in combat reported that the Panther could destroy a Sherman at ranges where the Sherman's gun could not even penetrate. And yet, American armored divisions kept pushing forward. Tanks that should have been destroyed kept returning to battle. Units that should have been crippled by mechanical losses kept pressing the attack. The reports from the front confused everyone who read them. American machinery broke down at rates similar to German equipment, sometimes worse. The Sherman's Chrysler multibank engine was known to be temperamental. The suspension had issues with the bogie wheels. The electrical system was prone to shorts in wet conditions. But somehow, American tanks returned to service faster, much faster. A damaged Panther required specialized repair teams, often transported from distant depots. A thrown track might take hours. A damaged transmission could remove a tank from service for a week, sometimes longer. Shermans with similar damage returned to the front lines in days, sometimes hours. The numbers made no sense until you stopped looking at the tanks and started looking at the system behind them. Kaufmann had begun to suspect this 3 months ago, reading after-action reports in a different depot in Sicily. American tank battalions maintaining operational rates that should have been impossible given their mechanical reliability. Keeping 70, sometimes 80% of their vehicles combat-ready, despite constant engagement. German units with superior tanks struggled to maintain 50%. It was not the machines, it was something else. Otto had pulled the Sherman's maintenance log from the tank before it was hauled away for scrap. He brought it to the workbench now, a small green notebook, water-damaged, written in English. "Can you read it?" Vogel asked. Some. Otto had worked with American machinery before the war, picked up enough English to handle technical documents. The entries are simple. He pointed to a line dated October 18th, 1943. Transmission fluid leak. Unit replaced. Time, 2 hours 15 minutes. Another entry, October 24th. Final drive gear noise. Unit replaced. Time, 1 hour 40 minutes. November 3rd. Transmission slipping under load. Unit replaced. Time, 2 hours. Replaced, replaced, replaced. Never repaired, never adjusted, never rebuilt in the field. Just swapped out like a bad light bulb. Vogel shook his head. Wasteful. A skilled mechanic could have repaired most of these issues in place. Could he? Otto looked up. How long to repair a slipping transmission on a Panther? Vogel hesitated. 6 hours, Otto answered his own question. Maybe 8, if the mechanic is experienced, if he has the right tools, if replacement parts are available, if nothing goes wrong. He tapped the American log. Their crew swapped the entire assembly in 2 hours, then drove the tank back into action the same day. Yes, but they wasted a perfectly serviceable transmission. Did they? Otto's voice was patient. They sent it to a rear depot. Perhaps someone there rebuilt it. Perhaps they scrapped it and recycled the metal. Either way, the tank was fighting again in 2 hours instead of waiting 8. Kaufmann was listening but not participating. His attention was on the Sherman transmission itself. He walked around the workbench slowly, looking at it from different angles. The housing was cast steel, American foundry work, not as refined as German casting but adequate, more than adequate. The mounting points were clearly visible, 8 bolts, standard hex heads. He could see from here that every bolt was the same size. On a Panther, the mounting bolts varied, different sizes for different stress points. It required keeping multiple socket sizes ready, required knowing which bolt went where. This was simpler, deliberately simpler. "We should disassemble it," Kaufmann said. "See what they have built." Vogel checked his watch. "Very well. I will return this afternoon for your initial assessment." He left. The door closed. The rain continued. Kaufmann and Otto looked at each other across the workbench. "What are we looking for?" Otto asked. "I am not sure yet." Kaufmann picked up a socket wrench. "But I think we will know it when we find it." They started with the basics. Kaufmann had disassembled hundreds of transmissions, Maybach units from Tigers, ZF units from Panthers. Each one was slightly different. Each one required attention to the individual characteristics of that specific vehicle. A good mechanic learned to feel these variations, to compensate for them. He expected the Sherman to be the same. It was not. The first bolt came free with exactly the torque he expected from the manual specifications, 95 foot-pounds. The second bolt, the same. The third, the fourth, all 8 mounting bolts, identical torque, identical positions, no variation. Otto noticed it too. They are all the same size. 19mm hex, Kaufmann confirmed. Every single one. On a Panther, you needed 4 different socket sizes just to remove the transmission. The Germans had designed it that way deliberately. Different bolts for different loads. Engineering precision. This was different precision. The precision of making everything identical. They rigged a chain hoist to the ceiling beam. Standard equipment in any maintenance depot. The manual specified a 2-ton capacity hoist. They had a 3-ton unit. It would work. Kaufmann positioned the hook under the transmission's lifting eyes, machined lugs on either side of the housing, clearly designed for exactly this purpose. "Ready?" Otto nodded. Kaufmann worked the hoist. The chain rattled. The transmission lifted free from its mounts. 45 minutes after they had started, the transmission sat on the floor beside the workbench. 45 minutes. Kaufmann had removed Panther transmissions that took 4 hours, required specialized pullers, required careful measurement of clearances because each vehicle was slightly different. This had been simple, almost insultingly simple. "Ernst," Otto was kneeling beside the transmission. "Look at this." The housing. Otto was running his hand over the casting, looking for something. "What am I seeing?" "That is the problem. You are seeing nothing." Kaufmann knelt beside him, looked closer. The casting was smooth, no visible tool marks, no evidence of hand finishing, no small imperfections that would indicate where a skilled worker had modified this specific unit to fit this specific vehicle. It was factory perfect, everywhere. "They did not hand-fit this at all," Otto said slowly. "No." Kaufmann stood, walked to the tool rack, found his precision instruments, the calipers he had carried for 10 years, Starrett brand, ironically, American-made, purchased before the war. He brought them back to the transmission. Otto watched as he measured the mounting bolt hole positions, compared them to the specifications printed in the American manual. First hole, diameter 0.876 inches, specification 0.875 inches plus or minus 0.003, within tolerance. Second hole, same. Third hole, same. Kaufmann measured each of the 8 mounting positions. Every single one fell within the specified tolerance. Most were within 0.003 inches of perfect. He sat back on his heels. "Check my measurements." Otto took the calipers, went through the same process, took his time, double-checked each reading. Same results. Vogel had said it was impossible. Impossible to maintain that kind of precision across different factories, across different production runs, across thousands of units. but here it was. The evidence sat on the depot floor in front of them, cast steel and machined precision. A transmission built in Fort Wayne, Indiana, that would fit perfectly into any Sherman hull built in Detroit or Cleveland or Grand Blanc. Not approximately, not with minor adjustments, exactly. Kaufman stood, walked to the window, looked out at the rain falling on the ruins of Tunis. Behind him, Otto's voice was quiet. If this transmission fits perfectly, if any transmission from any American factory fits any tank, Kaufman finished the thought, then they have built something we have not a better tank, a better system. They broke for lunch. Cold rations, weak coffee. The rain eased slightly but did not stop. Kaufman ate without tasting. His mind was elsewhere. On those 8 bolt holes, on that 0.003-inch tolerance maintained across an entire production network. On what that implied. German precision engineering was legendary, respected throughout the world. German factories produced some of the finest machinery ever made. The tolerances on a Panther transmission were tighter than what he had just measured on the Sherman. But that was not the point. The German tolerances were used to create perfect, individual fit. Each transmission was built to specification, then hand-fitted during installation. Adjustments made by skilled workers to compensate for the natural variations in any manufacturing process. This was different. The Americans had used precision for a different purpose entirely. They had used it to eliminate the need for fitting, to make adjustment unnecessary, to remove the craftsman from the process. Not because they could not find skilled workers, because they had designed a system that did not need them. Otto came back from outside, shook water from his jacket. Vogel is coming back early, wants preliminary results. What should we tell him? The truth. Kaufman stood, brushed crumbs from his lap. That we are beginning to understand why we are losing. He will not like that. No, but it is true anyway. Vogel arrived at 14:30 hours, impatient, expecting weaknesses identified, confirmation of what he already believed to be true. Well? Kaufman gestured to the disassembled transmission, to the notes he had made, to the measurements recorded in his careful handwriting. The Sherman transmission is interchangeable, completely. Any unit will fit any vehicle with no modification required. Yes, mass production. We know this. What is the weakness? Martin, you are not understanding. The precision required to achieve true interchangeability across multiple factories, multiple production runs, thousands of units. We do not do this. We cannot do this. Vogel frowned. Of course we can. German engineering is the finest in the world. Our engineering is excellent, but it serves a different purpose. Kaufman picked up one of the mounting bolts. We build precision to create optimized individual fit, each vehicle slightly different, each one requiring skilled installation. He set the bolt down. They build precision to eliminate the individual entirely. Every vehicle identical, every part interchangeable. No skill required for installation. That is inferior thinking. Is it? Otto spoke up. What happens when a skilled German mechanic is killed? Vogel turned to him. We train another. In how long? 2 years, perhaps more for transmission specialists. And until then? Silence. Otto continued. An American mechanic can be trained in 8 weeks. We found their training manuals, basic procedures, no theory required, just steps to follow. Mindless. Reproducible. Kaufman's voice was firm. When an American mechanic dies, they replace him in 8 weeks. The knowledge is in the manual, in the procedures, in the system itself. He met Vogel's eyes. When a German master mechanic dies, 15 years of accumulated knowledge dies with him. We have built a military that depends on exceptional people. They have built a military that functions with ordinary people. Vogel stared at him, then at the transmission, then back. You are saying we are doing it wrong. I am saying we are doing it differently, and in a war of attrition, their way works better. The rain picked up again outside, drumming on the metal roof, loud in the silence that followed. Finally, Vogel spoke. His voice was tight. I will need this in a formal report. Yes, sir. By the end of the week. Yes, sir.
Fogel looked at the manual on the workbench.
4 pages. Remove and replace. His jaw worked. This does not mean they are winning. No one answered that. Fogel left. The door closed. Kaufmann and Otto stood in the depot, alone with the transmission, with the manual, with the understanding that was forming like a weight in both their chests. Remove and replace. 3 words that changed everything. Not better engineering, different engineering. Engineering for war, engineering for survival, engineering for a world where nothing works perfectly, and the system that keeps functioning anyway is the one that wins. Outside, the rain continued to fall on the ruins of an empire that had built masterpieces, but forgotten to build systems. And somewhere across the Mediterranean, in factories in Indiana and Ohio and Michigan, ordinary workers were building ordinary transmissions to extraordinary precision, building them by the thousands, building them to win. November 19th, 1943.
Week 1 of the analysis.
Kaufmann arrived at the depot before dawn. The rain had finally stopped during the night, leaving the air cold and damp. Puddles reflected the grey sky. His breath made clouds in the unheated building. He had not slept well. Kept thinking about those 8 bolt holes, about precision used not for optimization, but for elimination. The idea kept turning over in his mind like a gear that would not seat properly. Otto was already there, had been there for an hour, judging by the coffee tin sitting empty on the workbench. Could not sleep either. No. Otto gestured to the transmission components spread across the floor. I started checking the other assemblies, the gear sets, the clutch plates, the drive shaft mounts. And, all identical to specifications, every single one. Kaufmann knelt beside the parts, picked up a clutch plate. It was stamped with a part number, 30238847. Thickness marked, 0.118 inches. He pulled out his micrometer, measured
0.1182 inches.
Specification allowed plus or minus 0.001 inches, well within tolerance. He checked another clutch plate, same part number, different production batch based on the date stamp, 0.1179 inches. Another, 0.1181 inches. Every single plate within a 2,000th band, on a component that would be replaced as a complete set, never individually adjusted, never hand-selected to match a specific transmission, just built to specification, installed, expected to work. And apparently, it did. The gear ratios, Otto said, first gear, second, third, fourth, reverse, all match the technical data exactly. No variation between this transmission and what the manual says every transmission should be. Kaufmann stood, brushed dust from his knees. So if this transmission is identical to specifications, then every transmission is identical to every other transmission. Otto's voice was flat, matter of fact. From any factory, any production run, any date.
The implication was staggering.
It meant the Americans had not just achieved interchangeability, they had achieved it at a scale that seemed impossible. Thousands of transmissions, tens of thousands, each one built to tolerances tight enough that any unit could replace any other unit with zero adjustment. On a Panther, each transmission had to be carefully matched to its specific vehicle during installation. The mechanics knew this, accepted it. It was simply how precision machinery worked. You built to specification, then adjusted for reality. The Americans had built to a specification so precise that reality matched it exactly. "We are looking at this wrong," Kaufmann said quietly. "How do you mean?" "We keep thinking about individual components, individual tanks, but that is not what they have built." He walked to the wall, found a piece of chalk, started drawing. A German Panther, beautifully engineered, every component optimized, a true masterpiece. He drew a box.
But each Panther is slightly unique, requires specialized knowledge to maintain, depends on skilled mechanics who know that specific vehicle. He drew another box beside it, a Sherman, adequately engineered, every component standardized, deliberately simple. He drew lines connecting dozens of smaller boxes to it. But every Sherman is identical. Any part fits any vehicle. Any mechanic can service any tank following basic procedures. Otto studied the drawing. You are saying they sacrificed individual optimization for system standardization? Yes, and in war, Kaufmann tapped the chalk against the wall, system wins. The depot door opened. Vogel entered, carrying a canvas bag. Intelligence delivered additional materials. He set the bag on the workbench, captured American training documents, course outlines for tank maintenance. I thought you might want to see how they train their mechanics. He said it with a slight sneer, as if the answer was already obvious. Kaufmann opened the bag. November 26, 1943. 1 week later. The training manuals had changed everything. Kaufmann sat at the workbench with documents spread in front of him. Course syllabi, lesson plans, training schedules, equipment lists, testing procedures. He had read through them twice, was now on his third pass, looking for what he had missed. The intensive theoretical foundation, the years of apprenticeship, the deep mechanical knowledge, it was not there. Standard Sherman tank maintenance course, duration 8 weeks. 8 weeks. He checked the document again. Surely there was a follow-on course, advanced training, specialist certification. Nothing. 8 weeks was the complete program. Otto looked over his shoulder, read the course outline. Week 1, basic tools and safety. Week 2, preventive maintenance procedures. Week 3, track and suspension. Week 4, engine systems. Week 5, transmission and drivetrain. Week 6, electrical and fuel. Week 7, weapons systems. Week 8, combat repairs and field procedures. He sat back. That is comprehensive. For 8 weeks. Look at the methodology. Kaufmann pointed to a section labeled Instructional Approach. He read aloud. Training will focus on procedural execution rather than theoretical understanding. Each maintenance task is broken into discrete, documented steps. Trainees will learn to follow procedures exactly as written. Diagnosis of novel problems is not expected at this level. When issues arise outside documented procedures, trainees will escalate to depot-level maintenance. Otto was quiet for a long moment. They are not training mechanics to think. They are training them to execute. Yes, Kaufmann found another document, testing requirements. He scanned the questions. Describe the procedure for replacing a final drive assembly. List the tools required. What is the specified torque for mounting bolts? If a replaced component fails initial operation test, what is the correct action? He looked up. These are not questions about understanding how the machinery works. These are questions about remembering procedures. And the answer to that last question? Kaufmann found it. Replace component again and send failed unit to depot for analysis. Not fix it, not diagnose the root cause, just replace it and move on. Vogel had been listening from across the room. Now he walked over. This is exactly what I expected. American training is superficial. They produce technicians, not craftsmen. This is a weakness, Ernst, not a strength. Is it? Kaufmann met his eyes. How long does it take to train a German panzer mechanic? A proper apprenticeship takes 2 years minimum, longer for specialists. And if that mechanic is killed? Vogel's jaw tightened. We train another. In 2 years, during which time his expertise is gone, his knowledge lost. Kaufmann tapped the American training manual. They can replace a mechanic in 8 weeks. The knowledge does not live in the person. It lives in the procedure, in the manual, in the system. That is not true knowledge. Perhaps not. Otto's voice was measured. But it is reproducible knowledge. And in war, that matters. He pulled another document from the stack. Field Maintenance Guide. Opened it to a random page. The page showed a transmission oil leak diagnosis chart, a flow chart, simple boxes and arrows. Is leak from front seal? Yes. Replace seal. No. Check rear seal. Is leak from rear seal? Yes. Replace seal. No. Check housing gasket. Is leak from gasket? Yes. Replace gasket. No. Replace entire transmission assembly. No mention of why the leak might be occurring. No discussion of worn bearings or misaligned shafts, or any of the dozen other factors that could cause oil leaks. Just a decision tree. Follow the path. Execute the solution. Kaufman imagined a young American soldier, maybe 19 years old, high school education, 8 weeks of training, handed this manual and a toolbox. Could he fix a transmission leak? Not the way a German master mechanic would, not by understanding the root cause and addressing it with precision and skill. But could he follow the flowchart? Check the seals, replace the gasket, get the tank operational again? Yes, almost certainly yes. I need to write this down, Kaufman said. He found paper, started making notes. German system. Create craftsmen, invest years, produce deep expertise. Result, exceptional capability. Limitation, small numbers, long replacement time. Knowledge dies with the individual. American system. Create executors, invest weeks, produce procedural competence. Result, adequate capability. Advantage, large numbers, fast replacement time, knowledge embedded in system. He underlined the last line twice. Knowledge embedded in system. That was the key. The thing he had been circling around for days without quite seeing it clearly. The Americans had not built better mechanics. They had built a better system for producing adequate mechanics at scale. And in a war where mechanics were being killed daily, where equipment was being destroyed faster than it could be replaced, where the side that kept more tanks running would eventually win, adequate at scale beat exceptional in small numbers. Vogel read over his shoulder. His face darkened. You are suggesting we abandon German craftsmanship? Years of tradition? The very thing that makes our engineering superior? I am suggesting, Kaufman said carefully, that we are fighting a different kind of war than we prepared for, and the enemy adapted faster than we did. Outside, a truck rumbled past, carrying more salvage from the battlefield, more destroyed equipment, more evidence of a war that was not going the way anyone had planned. December 3rd, 1943. Morning frost on the windows. A new delivery from intelligence. A sealed shipping crate. American. Captured intact from a supply convoy that had been hit by Stukas near Bizerte. Vogel and Otto helped Kaufman lever the lid open. Inside, a replacement transmission assembly, still in its original packing, cosmoline preservative coating every metal surface, a tag wired to one of the lifting eyes. Kaufman read the tag. Fisher Tank Arsenal, Fort Wayne, Indiana. Unit serial number 47,821. Manufactured October 1943. Inspected and approved for shipment November 2nd, 1943. Beneath the unit, he found a folder. Quality control documentation. He opened it carefully. Inside, an inspection card. Printed form with blank spaces filled in by hand. 17 separate measurements listed, each one with a specified tolerance range, each one checked and initialed by an inspector. The signatures were dated November 2nd. 3 different inspectors had signed off. Different shifts, judging by the times noted. First shift, 0640 hours. Inspector signature, R. Patterson, employee number 3847. Second shift, 1520 hours. Inspector signature, B. Morrison, employee number 4521. Third shift, 2330 hours. Inspector signature, J. Williams, employee number 5103. Otto noticed it first. Betty Morrison. What about her? That is a woman's name. Kaufman looked closer at the signature. The handwriting was neat, careful, each letter precisely formed. He found additional documentation in the folder, personnel file copies, apparently shipped with the unit for some bureaucratic reason. Morrison, Betty Ann, employee number 4521, hired August 18th, 1943. Previous occupation, school teacher. Training period, 12 weeks. Current assignment, quality control inspector, final assembly, second shift. Kaufman read it again. A school teacher. Hired 3 months before this inspection. 12 weeks of training. Now responsible for verifying that a combat transmission assembly met 17 critical specifications to tolerances measured in thousandths of an inch. This cannot be correct, Vogel said. He was reading over Kaufman's shoulder. A woman, with no manufacturing background, inspecting military equipment after 3 months. But the evidence was there. The inspection card, the measurements recorded, the tolerances verified. Kaufman found the procedure manual that had been included in the shipment, quality control protocols. He read the section on transmission inspection. The process was described in exact detail. Which measurement tools to use. Starrett gauge blocks accurate to 0.0001 inches. How to zero the instruments. How to take each measurement. What the tolerance band was for each dimension. What to do if a measurement fell outside tolerance. If any measurement exceeds specified tolerance, reject unit and tag for rework. If all measurements fall within tolerance, approve for shipment and sign inspection card. No engineering judgment required, no years of experience needed, just the ability to read a micrometer. Follow a procedure. Check whether a number fell inside a range. Otto was examining the gauge blocks that had been included in the crate. Precision measurement standards. He held one up to the light. These are expensive tools, high quality. Yes. They gave them to factory workers with 12 weeks training. Yes. Because the process makes the quality, not the person's expertise. Kaufman set down the inspection card, looked at the transmission assembly sitting in its crate, built in Indiana, inspected by a former school teacher, shipped across the Atlantic, would have been installed in a Sherman hull somewhere in North Africa, would have functioned perfectly, because the system guaranteed it would. A German transmission required a master mechanic to verify quality. A man who knew by feel and sound and years of accumulated experience whether a unit was properly assembled. An American transmission required someone who could read a gauge and compare numbers. Different philosophies, different results. How many factories are building these? Otto asked. Kaufman checked the documentation, found a routing slip that listed depot codes. This came from Fort Wayne, but I see reference codes for Cleveland, Detroit, Grand Blanc. He looked up. At least 4 major facilities, possibly more. All building to identical specifications? Yes. All using the same quality control procedures? Yes. All capable of producing transmissions that fit any Sherman anywhere? Yes. Vogel walked to the window, stared out at the grey morning. His hands were clasped behind his back. When he spoke, his voice was tight. We cannot compete with this. It was the first time Kaufman had heard him admit it. December 10th, 1943. More intelligence documents. Factory network analysis. Production statistics. Facility locations. Kaufman spread them across the depot's concrete wall, used pieces of string to connect related documents, creating a map of the American production system. Fort Wayne, Indiana. Transmissions and final drives. Cleveland, Ohio. Transmissions and engines. Detroit, Michigan, complete powertrains. Grand Blanc, Michigan, hull assemblies. Chrysler Tank Arsenal, final assembly. Fisher body, multiple components. Each facility connected to multiple suppliers. Each supplier connected to multiple facilities. A web of production that spread across the American industrial heartland. Otto stood back, studied the map. If one factory is destroyed, the others increase production to compensate. Kaufman drew the conclusion he had been avoiding for days. There is no single essential facility, no bottleneck, no critical vulnerability. He found a document comparing American and German production systems. Intelligence analysis, dry, statistical, devastating. German Panther production, primarily MAN and Daimler-Benz, specialized facilities, unique tooling, concentrated expertise. Current output,
approximately 200 units per month. Vulnerability, high. Disruption of either facility significantly impacts total production. He turned to the American section. Sherman production, multiple contractors, standardized specifications shared across all facilities, interchangeable tooling, distributed expertise. Current output, approximately 2,000 units per month. Vulnerability, low. No single facility essential to maintaining production capacity. 200 versus 2,000, 10-to-1 ratio. And that was just tanks. The same pattern repeated across every category. Trucks, artillery, aircraft, ships. Mass production at a scale Germany simply could not match.
"We knew they had more factories," Vogel said quietly. He had been watching Kaufmann work. "That is not new information." "No, but I did not understand what it meant." Kaufmann turned to face him. "I thought it meant they could produce more individual units. That is true. But it is not the important part." He gestured to the map on the wall. "What this means is that their production system cannot be stopped. You can bomb Fort Wayne, Cleveland keeps building. You can bomb Cleveland, Detroit keeps building. You can bomb all three. The tooling specifications are shared. They can bring new facilities online in months. We can bomb their new facilities too." "With what?" Otto's voice was blunt. "We cannot reach Indiana from here, cannot reach Michigan or Ohio. Our strategic bombers do not have the range, cannot get past their air defenses even if they did." Silence. Kaufmann continued. "Meanwhile, our Panther production is concentrated at MAN in Nuremberg and Daimler-Benz in Berlin. Facilities the Americans can reach, will reach, are already reaching." He found another document. Bomber command reports, damage assessments. MAN facility struck August 1943. Production disrupted for 6 weeks. Daimler-Benz struck September. 3 weeks disruption. He looked at Vogel. "What happens when both are hit simultaneously? When production stops completely for a month? 2 months?" No answer, because they all knew the answer. The Americans had built redundancy into their system at every level. Component suppliers, assembly facilities, quality control, logistics, training. Germany had built efficiency, concentrated expertise, specialized excellence. In peacetime, the German system produced better results. In total war, the American system survived. December 17, 1943. Kaufmann was writing the analysis section of his report. Battlefield implications. The part Vogel had specifically requested. What does this mean for our units in the field? He started with scenarios, concrete examples. Scenario: Panther transmission failure during engagement. He wrote out the sequence. Tank commander reports failure. Crew performs field assessment. Damage beyond field repair. Requires replacement assembly. Contact division maintenance. Request specialized recovery team. Wait. Recovery team assembles. Loads specialized tools. Travels to disabled tank location. Could be 5 kilometers. Could be 50. Arrives. Begins extraction. Panther transmission requires custom pullers, alignment jigs, precision measurement tools, experienced team, maybe 4 to 6 hours for removal and replacement. But that assumes everything goes right. Assumes team arrives. Assumes replacement transmission available. Assumes it matches the vehicle variant. Assumes supply line intact. Reality: 3 to 7 days before tank operational, sometimes longer, sometimes never. He had seen the reports. Panthers abandoned because recovery teams could not reach them, because spare transmissions were not available, because the part that arrived did not fit the specific variant. Masterpiece engineering, defeated by logistics. He started the next scenario. Scenario: Sherman transmission failure during engagement. Same starting conditions. Transmission damaged, beyond field repair. Crew performs assessment, consults manual. Confirms, replace assembly. Contact battalion supply. Request replacement transmission. Any transmission. They are all identical. Supply sergeant checks inventory. Forward dump has 17 transmissions in stock. Sends one forward on next supply run. Unit arrives. 3-man crew. Standard chain hoist. Basic tools. Manual procedure. disconnect 4 electrical connections, disconnect 2 fluid lines, remove 8 mounting bolts, lower assembly, install replacement, reconnect, refill fluids. Test. Time, 90 minutes to 2 hours. Tank operational same day. Kaufman sat back, read both scenarios. The individual Panther was superior in nearly every metric. Better armor, better gun, better optics. In a direct engagement, one-on-one, the Panther would win. But wars were not fought one tank at a time. Wars were fought by armies, hundreds of tanks, thousands, engaging across weeks and months and years. And in that contest, availability mattered more than individual superiority. A Panther fighting for 3 days, then waiting 5 days for repairs, then fighting 2 more days, then waiting again, versus a Sherman fighting for 3 days, swapping transmissions in 2 hours, fighting 3 more days, swapping an engine in 3 hours, fighting 5 more days. Over time, the Sherman accumulated more combat hours, more presence on the battlefield, more pressure on the enemy. The mathematics were brutal. He wrote in his report, "Our entire doctrine assumes supply lines hold, assumes parts arrive, assumes time to repair. Their doctrine assumes none of that, assumes chaos, designs for it." Otto read over his shoulder. "Vogel will not accept this." No, but it is true anyway. Outside, the sound of distant artillery, the war continuing, the Americans advancing, the Germans retreating, slowly, steadily. Kaufman picked up his pen, kept writing, the report that would be ignored, the truth that would change nothing. Because understanding was not power. Power was the ability to act on understanding, and Germany no longer had that ability. The factories were already built, the workers already trained, the doctrine already fixed in place by decades of tradition and millions of Reichsmarks in sunk costs. You could not retool an entire industrial system in the middle of a war. You could only watch as the system you had built proved inadequate to the world it now faced. Kaufman wrote late into the night, recording what he had learned, knowing it was too late to matter. December 23rd, 1943. The report was finished. 63 pages. Technical diagrams, measurement tables, statistical analysis. Kaufman's careful handwriting filling every sheet. He sat at the workbench in the empty depot, just past midnight, a single electric bulb hanging from the ceiling, his shadow stretching across the concrete floor. The report detailed everything: modular design philosophy, interchangeable component precision, simplified training methodology, distributed production redundancy, availability-focused maintenance doctrine, every discovery from the past 6 weeks, every implication, every conclusion he wished he had not reached. Otto had helped with the technical sections, measurements, tolerances, production capacity comparisons, the two of them working in silence most evenings, both understanding what this report meant, both knowing it would change nothing. Kaufman read through the summary section one final time. The American approach represents a fundamental reconception of industrial warfare. They have not built superior individual machines, they have built a superior system for producing, deploying, maintaining, and replacing adequate machines at scale. This system is designed to function in chaos, to survive disruption, to continue operating when individual components fail. He paused, pen hovering over paper, added one more line. We built vehicles that perform brilliantly when conditions are perfect. They built vehicles that continue functioning when conditions are terrible. War is terrible conditions. The clock on the wall ticked. 00:47 hours. December 24th now, Christmas Eve. Somewhere in Germany, families would be gathering. What families remained? Trying to maintain traditions in a world that had stopped making sense. Kaufman had no family left, his wife dead in the Berlin bombing raids, no children, just a younger sister in Hamburg and her son, his nephew, Friedrich, 22 years old, panzer commander somewhere on the Eastern Front. He thought about Friedrich, driving a Panther, trusting that German engineering would keep him alive, trusting that the supply system would provide parts when needed,
trusting that the expertise built into every component would prove superior to Russian numbers. Kaufmann hoped it would, but he no longer believed it. He signed the report, dated it, placed it in a folder. Tomorrow, he would give it to Vogel. Vogel would send it up the chain of command, to division, to corps, to high command in Berlin. And then nothing would happen. Because you could not change a system from within when you were part of what needed to change. December 24th, 1943, morning. Vogel arrived at 0900, punctual as always. He wore his dress uniform, probably had Christmas services to attend later.
Kaufmann handed him the folder. The analysis is complete. Vogel took it, weighed it in his hands, opened to the summary page, read in silence. His expression did not change, but something in his posture shifted, a tightening across the shoulders. This is your assessment? That American methods are superior? Not superior, different, adapted to different circumstances. It reads like defeatism. It is realism. Vogel closed the folder, set it on the workbench. I cannot submit this as written. High Command will see it as damage to morale. Criticism of our entire industrial approach. It is criticism of our industrial approach. Then it cannot be sent. Otto spoke from across the room. He had been listening quietly. Martin, if our commanders do not understand what they are facing, how can they adapt? They understand perfectly well. We are facing an enemy with more resources, more factories, more men. This is not new information.
But the why matters, Kaufmann said. They have more resources because their system uses resources more efficiently. They do not need master craftsmen because they have embedded the knowledge in procedures. They do not need specialized tools because they have standardized components. They do not need... Enough! Vogel's voice was sharp. I will submit your report, but I am required to add my own assessment, and I will note that these conclusions, while technically interesting, do not change our strategic situation. Our strategic situation is that we are losing. We are fighting. We are dying. Otto's voice was flat, factual. I read the casualty report same as you. We lose ground every week, every month. The Americans push forward. We fall back. This is not temporary. This is the pattern. Vogel picked up the folder again, held it like it weighed more than it should. What would you have me do? Tell High Command to abandon German engineering tradition, retool every factory, redesign every weapon system? In the middle of a war we are already fighting. No, Kaufmann said quietly, because it is too late for that. Then what is the point of this report? So that someone knows, so that someone understands why we lost, when it is over, when people ask how this happened. He gestured to the Sherman transmission still sitting on the workbench, 6 weeks old now, a museum piece, an artifact of a philosophy that had defeated them. So they know it was not because our soldiers were not brave enough, not because our generals were not skilled enough, not because our engineers were not brilliant enough. He met Vogel's eyes. But because we built a system that requires everything to work perfectly, and they built a system that assumes nothing will. Silence. The electric bulb buzzed overhead. Somewhere outside, a truck started, diesel engine coughing to life in the cold. Vogel tucked the folder under his arm. I will submit this today. Expect no response before the new year. He left. The door closed. Otto walked to the workbench, picked up the American manual. 4 pages. Remove and replace. He is right, you know, about it being too late. I know. We cannot change, not fast enough, not completely enough. I know. So we just continue, knowing it will not work? Kaufmann did not answer immediately. He looked at his hands, scarred from 15 years of work, calloused from holding tools, trained to feel the alignment of gears by touch, hands made for a world that no longer existed. We continue because we are still at war, because our soldiers still need their tanks maintained, because stopping is not an option. He picked up a wrench from the tool rack. But yes, knowing it will not be enough. January 18th, 1944, 3 weeks since the report was submitted. Kaufmann was repairing a Panther transmission when Vogel brought the response. A single sheet of paper, typed, brief. He wiped grease from his hands, read it. Report reference TK4431943, received and reviewed. Technical analysis noted. Conclusions regarding American production methods are interesting from academic perspective, but do not alter current operational doctrine or procurement strategy. Continue standard maintenance operations as assigned. Signed by some Oberst at corps level. A name Kaufmann did not recognize. Filed and forgotten. He read it again, looking for something else, some indication that someone had understood, that the implications had been grasped. Nothing. Just acknowledgement and dismissal. Otto looked over his shoulder. That is it? That is it. 6 weeks of work, 60 pages of analysis, and we get 5 lines telling us to continue as before. Yes. Vogel stood in the doorway, uncomfortable. I told you they would not change anything.
You did. The system is too large, too committed. We have built everything around one approach. You cannot simply abandon it mid-war.
No, you cannot. Kaufmann folded the letter. Then he did something unexpected. He walked to the window, looked out at the depot yard. Broken Panthers waiting for parts. Otto appeared beside him. 5 lines, Otto said quietly. 63 pages, reduced to 5 lines. They understood, Kaufmann said. They just cannot change. Cannot or will not? Does it matter? Kaufmann turned from the window. The factories are tooled, the workers trained, the vehicles designed. You cannot rebuild an industrial philosophy in the middle of a war. Then we just continue. Until it ends, yes. Otto was quiet for a long moment. I have a son, 17. They will conscript him next year. Kaufmann looked at him, had not known this. I am sorry. He will drive a Panther, or a Tiger, a masterpiece of engineering. Otto's voice was hollow.
And he will wait for parts that will not come, just like all the others.
Kaufmann had no answer to that, because it was true. He placed the letter in his toolbox, next to the American manual, documents from different worlds. He went back to work on the Panther transmission, hand-fitting the gear set, measuring clearances with precision instruments, adjusting, testing, adjusting again. 8 hours of skilled labor to rebuild what an American crew would replace in 90 minutes. It felt different now. Before, this work had been satisfying. The application of expertise, the creation of precision, the pride of craftsmanship. Now it felt futile. He was performing surgery on a patient already dying. Doing it beautifully, doing it skillfully, but doing it too slowly to matter. The weeks blurred together. January became February, February became March. More tanks arrived, more repairs, more reports from the front of American advances, of German retreats. The pattern held.
Panthers superior in direct combat, but constantly sidelined by maintenance, by parts shortages, by the simple reality that keeping them operational required resources Germany no longer had in sufficient quantity. Shermans adequate in direct combat, but constantly available, constantly pressing, constantly there. And presence, Kaufmann had learned, mattered more than superiority. The depot had settled into routine, wake, work, sleep, the mechanics of survival replacing the hope of victory, until March 7, 1944, the day the letter arrived. It came with the regular mail delivery, forwarded through military postal service, already 3 weeks old based on the postmark. Eastern Front, Ukraine sector. Return address, 1st Panzer Division, Tactical Command Post. But the handwriting was not Friedrich's. Kaufmann's hands shook slightly as he opened it. The letter was from Friedrich's company commander, Hauptmann Werner Dietrich, a man Kaufmann had never met. He read, Herr Kaufmann, it is my difficult duty to inform you that your nephew, Oberleutnant Friedrich Kaufmann, has been taken prisoner by Soviet forces. The circumstances are as follows. The letter detailed an engagement near Korsun, Soviet offensive, German forces retreating,
Friedrich's Panther Ausf A, suffering mechanical failure during the withdrawal. Transmission. The main gear set had failed, teeth stripped under load, a not uncommon failure, repairable under normal circumstances, but these were not normal circumstances. Friedrich had radioed for recovery, for specialized maintenance team, for replacement parts. Division headquarters acknowledged, dispatched a recovery team from Lvov, 180 kilometers away. Friedrich and his crew waited. The letter continued. The recovery team departed Lvov on February 19th. They were carrying the required transmission components. However, Soviet air activity had intensified in the sector.
On February 20th, a Sturmovik attack struck the supply convoy approximately 40 kilometers from Oberleutnant Kaufmann's position. The recovery vehicle was destroyed, all replacement parts lost. Kaufmann stopped reading, closed his eyes, counted to 10, opened them, continued. Division attempted to dispatch a second recovery team. However, the tactical situation had deteriorated. Soviet forces were advancing rapidly. On February 25th, after 6 days immobilized, Oberleutnant Kaufmann made the decision to destroy his vehicle and attempt to reach German lines on foot. His crew was intercepted by Soviet advance elements, approximately 3 kilometers from the disabled Panther. Based on Red Cross information received March 1st, all crew members are confirmed captured and currently held as prisoners of war. The letter concluded with formal condolences and assurance that Friedrich was uninjured. Kaufmann set the letter down, stood, walked outside. The depot yard was empty. Grey sky, cold wind, broken tanks in rows.
He walked to the nearest Panther, climbed onto the hull, sat on the turret roof. His hands were shaking now. 6 days. Friedrich had waited 6 days for a gear set. Kaufmann had spent 15 years learning to rebuild gear sets, by hand, with precision tools, making them perfect, and Friedrich had died waiting for one. Not died, captured. But the distinction felt thin. If Germany had built Sherman-style systems, if the gear set had been in a forward supply dump 3 kilometers away instead of Lvov, 180 kilometers away, if any gear set fit any transmission, if replacement took 90 minutes instead of requiring specialized recovery teams, Friedrich would be free. But Germany had built masterpieces instead, and masterpieces required perfect conditions, and war destroyed perfect conditions. Kaufmann sat on the cold metal turret for 20 minutes, then climbed down, went back inside, returned to work.
Because there was nothing else to do.
October 1944. The war had moved on. The depot in Tunis was now far behind the lines, American lines. The Wehrmacht had retreated from North Africa entirely. Sicily fallen, Italy invaded. Kaufmann and Otto had been reassigned, sent back to Germany, to a depot outside Munich, repairing tanks that came back from the Western Front. If they came back. More often they were simply abandoned, left where they broke down, crews escaping on foot. No recovery teams, no spare parts, no time. The reports crossing Kaufmann's desk told the story in numbers. American tank production 1943 through 1944, 49,234 Sherman tanks. German production, same period, 6,000 Panthers, 8-1. For every German tank destroyed, America built 8 more. For every German mechanic killed, America trained 15 in 8-week courses.
For every German factory bombed, America had 20 already operating at full capacity.
The mathematics were inexorable. Kaufmann had stopped hoping the system would change, had stopped believing that someone higher up would understand, would adapt. The response to his report had made that clear. Continue standard operations. So he did. He repaired Panther transmissions, hand-fitted each gear, spent 8 hours on work an American crew would complete in 90 minutes. Did it perfectly. Watched the tanks return to the front, watched them come back broken, watched them not come back at all. Late November 1944, a Panther arrived at the depot. Transmission failure. Crew exhausted. They had driven it 300 kilometers with the transmission slipping.
nursed it along because there were no recovery teams available, no spare parts in the supply system. Kaufman examined the damage: complete internal failure, gear teeth stripped, shafts scored, housing cracked. Irreparable, he told the crew. They nodded. They had expected it. "How long for a replacement?" the commander asked. Kaufman checked the supply logs, looked at the requisition system, saw the reality that everyone was trying not to acknowledge. "There are no replacement transmissions available in this sector. I have requisitioned 3 units. None have arrived. The factories are struggling to maintain production under air raids." "So what do we do?" "Wait." "For how long?" Kaufman met the man's eyes, saw the exhaustion there, the understanding that waiting might mean forever. "I do not know." The crew left. Their Panther sat in the depot yard. Beautiful machine, advanced engineering, sophisticated design, broken, awaiting a part that would probably never arrive. Kaufman went to his office. Small room, concrete walls, a desk, a filing cabinet. He opened the cabinet, found the American manual, TM9-731B. Still there, still 4 pages. Opened it. Transmission assembly, removal and installation. The procedure he had read 100 times now. Simple steps, standard tools, 90 minutes. He imagined this Panther as a Sherman. Imagined the crew calling for a replacement transmission. Imagined it arriving from a forward supply dump within hours. Imagined them installing it, refilling the fluids, testing. Imagined the tank operational again by evening. Instead, this Panther would sit. For days, for weeks, until a specialized unit arrived from a factory that was probably already bombed. Until parts were available that were probably already diverted to another sector. If ever. He sat at his desk late into the night. The depot was quiet. Most of the crews had left. Just him and the broken Panther outside. He thought about Friedrich, somewhere in a Soviet prison camp, alive, according to the Red Cross reports, but a prisoner, because a gear set never arrived. He thought about Betty Morrison in Fort Wayne, Indiana, a schoolteacher turned quality inspector, following procedures, checking measurements, approving transmissions that would fit any Sherman anywhere. He thought about the young American crews, 8 weeks of training, basic procedures, no deep expertise, but enough to keep tanks running, enough to keep fighting. He thought about his own hands, 15 years of skill, the ability to diagnose a transmission problem by sound, to hand-fit gears to tolerances measured in thousandths, to create perfect mechanical precision. Skills that were beautiful, skills that were obsolete. The radio in the corner was playing, low volume, news from the front. Allied forces had crossed the Rhine. The war was coming to Germany now, to the factories, to the cities, to the system that had built masterpieces but forgotten to build resilience. Kaufman turned off the radio, looked at the American manual one more time. 4 pages, remove and replace. The philosophy that had defeated the craftsman. Not because it was better, but because it survived. And in war, survival was victory. May 8, 1945. The war ended. Ernst Gottfried Kaufmann stood in the ruins of the Munich depot. Allied bombers had hit it 3 times in April. The roof was gone. Most of the walls collapsed. The Panther he had been repairing sat buried under rubble. He was 54 years old, looked 70. The Americans arrived that afternoon. Military government, engineers. They catalogued equipment, inventoried tools, asked questions. One of them, a young captain, picked up the American manual from Kaufmann's salvaged toolbox. TM9-731B, water damaged, burnt at the edges, but intact. "You kept this?" Kaufmann nodded. "Why?" "To remember." "Remember what?" "Why we lost." The captain looked at him, looked at the manual, did not understand. How could he? The Americans had won. Their system had worked. They would never need to learn the lesson Kaufmann had learned, that masterpieces are beautiful. But systems survive. Ernst Gottfried Kaufmann survived the war. He worked briefly for the American occupation forces, translator, technical advisor.
then returned to civilian life. In 1949, Volkswagen hired him. The company was rebuilding, applying American mass production methods, standardized components, interchangeable parts, simplified assembly. Everything Kaufman had written about in his 1943 report. He helped design their new training program. 8 weeks for basic mechanics, procedural, step by step. Knowledge in the system, not the person. It felt like betrayal at first, of his father, his grandfather, the tradition of German craftsmanship. But it worked. And Kaufman had learned that working mattered more than beautiful. Oberleutnant Friedrich Kaufmann did not survive. He died of typhus in a Soviet prison camp in March 1945, 2 months before Germany surrendered, 6 days before his 23rd birthday. The Red Cross notification reached Kaufmann in July 1945. He received it alone, read it alone, wept alone, then placed it in his toolbox, next to the American manual, next to his own report from 1943, documents of what had been lost, and why. Technical Manual TM9-731-B survived them both. After the war, German engineers studied it, Japanese engineers studied it. The principles spread: standardization, interchangeability, procedures over expertise, systems over individuals. The philosophy that had defeated the craftsman became the foundation of post-war manufacturing. Toyota production system, lean manufacturing, just-in-time delivery, quality by process, not by person. All descendants of those 4 pages: remove and replace. The philosophy that changed not just war, but industry itself. Germany rebuilt, became an economic powerhouse, produced cars and machines sold worldwide. By learning the lesson Kaufmann had tried to teach in 1943. But it was too late for the war. Too late for Friedrich. Too late for the 50,000 other Germans who died waiting for parts that never came. In 1963, Kaufmann retired from Volkswagen. He was 71. His hands could no longer hold tools steady, could no longer feel the alignment of gears. On his last day, the plant manager gave him a gift, a precision caliper, Starrett brand, American, like the one he had used in Tunis 20 years before. Kaufmann held it, felt its weight. "I spent 15 years," he said quietly, "learning to make things perfect. And I learned that perfect is the enemy of enough." He handed the caliper back. "Give it to a young engineer. Tell him to use it to make things right. Not perfect, just right enough to work." Ernst Gottfried Kaufmann died in 1967. He was buried in Munich, beside his wife, who had died in the bombing raids he had tried to prevent. His toolbox went to a technical museum, on display, a relic of a different age. Inside it, an American manual, 4 pages, remove and replace. The document that had shown him the future, too late to save the past. Wars are not won by the best weapons. They are won by the best systems for producing, deploying, maintaining, and replacing weapons at scale. Germany asked, "How do we build the best tank?" America asked, "How do we keep the most tanks fighting?" Different questions, different answers. One question built masterpieces that needed everything to work perfectly. One question built systems that assumed nothing would. And when nothing worked perfectly, as nothing ever does in war, the system that could still function was the system that won. Not because it was more elegant, not because it represented superior engineering, not because it reflected greater skill or deeper understanding, but because it kept functioning when everything else had failed. And in war, functioning is everything.